Hello everyone, we are live and we'll do another session on data sufficiency, which we have done last time also, and we have looked at the concepts around it, how to approach these questions. Now, we discussed that although Snap has not asked data sufficiency questions in quite some time, nonetheless, we should be aware about the pattern because, well, it can come up any time, right? So we should be aware about it. We should know how to approach these questions. So the way we get questions right are either MCQ, are mostly MCQ. CAT does ask some TETA, type in the answer type questions. So data sufficiency is another format of questions, right? So let me quickly recap, although we have done this last time, but let's have a quick recap of, first of all, how do we approach these questions, right? Because they require a little bit different mindset. And then by doing the problems, we will understand, you know, what are the nuances on how to navigate through this. Okay, so let's see. So first of all, you can check out our module of snaps at an NMET online classes. Check out these details if you're looking out for some module on these exams apart from CAT, right? CAT we know is happening tomorrow, but snaps at NMET on of these are also equally important. Okay, so here we go. Now concept. First of all, let me show you the first question so that we can get the idea that how the questions look like. This is the standard format of all questions. We'll do these questions shortly. So for example, what is Chintu's age? That's a question. So every DS questions has a problem statement at the top, followed by two statements numbered as 1 and 2, which gives some further conditions or information required or helpful to be able to answer the question asked. And then these are the standard options. You can see 5 options here, right? Because data sufficiency was something that was started by GMAT, which always asks questions in terms of 5 options. Indian exams also have incorporated data sufficiency from time to time, and sometimes they come with 5 options, sometimes with 4 options. Whenever they come with 4 options, somehow these options are you know uh, manipulated in such a way that these 5 outcomes are compressed in 4 options, right? Uh, so we will answer as if through these 5 options, and then whatever manipulation is there, we can always look at that, right? So this question at the top may or may not contain some information followed by these two statements. So what we have to do is we have to do two independent analysis, right? What we have to do, we have to do two independent analysis. So there is this question statement at the top, right? Plus additional information which may or may not be there. So I'm saying this is optional, right? Followed by statement 1, statement 2, right? So what we have to do, we have to do two independent analysis, which means we have to look at statement 1 and we have to combined with any information if there is at the top, we have to analyze that can we answer the question asked. The the main motive is to figure out whether sufficiency is achieved or not. So important thing to understand is what is the meaning of sufficiency. Sufficiency means uniqueness. Are you getting a unique answer or not to the question asked? Is there exact precise uh, answer or not? The questions which are asked can be of two types. Questions can either ask some value. What is, we just saw what is Chintu's age, right? So that was a value. Or it could be a binary kind of question. What is binary? Something which has only two outcomes, a kind of a yes no question. Or maybe is X even or odd? So something which, only asks a question which can only have two answers, right? So that's what I call a binary question. So either whether it's a value or whether it's a binary question, we are looking for uniqueness. So uniqueness means if it's a value, then we should get an exact precise value. There should be no two possibilities. For example, if I say x square is 25, then if I'm trying to find x, then this statement is not sufficient to answer the question. because although we can solve the equation, we know how to solve, but we don't still know what is exactly. It may be plus 5, it may be minus 5. So that's the main thing. Likewise, in a yes no type question, or those questions with two possibilities, is n even or odd, those kind of questions, we're looking for again an exact answer, whether this or that. So if it's a yes no question, and if after analyzing the statement we have got a definite no to the question asked, that also is sufficiency, because we've got the unique answer, right? So we have to do two independent analysis. Statement one, is it sufficient or not? There are two possibilities. It may be sufficient, it may not be sufficient. Option two, statement two, again do second analysis. Is it sufficient or not? Yes or no. So uh, overall, after doing these two analyses, we will have four possibilities. Either statement one is sufficient, but statement two is not, or statement one is not sufficient, but statement two is sufficient, or it could be that statement one is also sufficient, statement two is also sufficient, or it could be that none of them are sufficient. From the five options that we saw in the next slide, option A says statement one alone is sufficient, but statement two is not. So this is matching with the first outcome. Option B says statement 2 alone is sufficient, but statement 1 alone is not sufficient. That is matching with the second possibility. Option C is both statements together are sufficient. So we have not yet analyzed them together. Option D is each statement alone is sufficient. So this is matching with the third outcome. Option E is both statements together are also not sufficient. So what it looks like, that based on this, we would say answer option A if this is the possible, is if this is what we have got. We will say answer B if this is the combination of, you know, statements in terms of their sufficiency. This is option D, each statement alone is sufficient. Now, so if any of these three outcomes are there, then we are done. There is nothing else that we need to do. So in data sufficiency, what mostly people forget is we don't necessarily need to combine the statements. That's the main thing that people forget, or they think that, you know, we have to just solve, so just merge the two statements and just start solving the question. That is not how we go about data sufficiency, right? So we are required to combine the statements only when both statements individually do not give a sufficient answer. Only in that case we now do a third analysis, combine and then analyze. Are we able to now get a unique answer or not? If we are able to get, then C is your choice. If still not, then E is your correct answer. Okay, so that's a proper algorithm, or the approach how you should always deal with data sufficiency, right? So that's the main style. Okay, now through problems we will understand uh, what are the nuances of handling these questions. Let's start, right? Let's therefore begin. Okay, so you can try with me, you can share with me your answers. These are the five standard options. In case you get the answer faster than me, please type in your answer on the chat box, right? So that I can also be aware that you are also participating. Let's start. What is Chintu's age? Very good, let's start. So standard proper variable based question, let's say Chintu's age is X, right? So if Chintu's age is X, then statement one, is it sufficient? Chintu's age is 1/5 of his father's age and 1/5 of his mother's age does not help me anything. Now in data sufficiency, the most important thing is that a particular statement, if it is not sufficient, don't just say we don't need to do anything. Because what happens is, let's say statement one, obviously it is not sufficient because we don't know any number, right? So, but we know that if statement one fails and if statement two also fails, then we need to combine. So whatever you are given from the information, you do your analysis, you do your inferencing from it. Means what can you conclude from it? So in case, so therefore you are ready that when both the statements fail, then we are ready to combine them and analyze, right? So on the face value itself, I can clearly reject statement one because obviously it does not give me any number for the age of any person. So statement one is not going to be sufficient. Come to statement two, 5 years hence, Chintu's mother will be as old as Chintu's father is today. So talking about mother and father, how does that help me to find the current age of Chintu? Again, statement 2 is clearly not sufficient. So rejecting the statements on their own is very quick, and therefore we can now directly combine. We know, right? So therefore that process of is this statement sufficient or not can be sometimes very quick, right? Because you're doing analysis, right? Remember, you're not solving. DS problem, you are not supposed to find to I mean, you don't need to report the value of the answer. You just need to analyze, will you be able to solve or not? That's the point, right? So now therefore we combine. So by combining statement 1, we get that, okay, Chintu's age is 1/6 of father's age, means father is 6 times of Chintu. So father's age is 6x, right? Likewise, mother's, so one and Chintu's age is 1/5 of mother's age, or other way around, mother's age is 5 times. So mother is 5x. And then from the statement 2, 5 years hence, Chintu's mother will be as old as Chintu's father is today. So Chintu's mother is right now 5x. 5 years hence, she will be 5x plus 5. And this will be equal to the present age of Chintu's father, which is 6x. So yes, after combining, we are able to solve for the value of x. X is 5, right? So option C makes sense, right? Okay, so we'll look at several problems in today's session. I think we have just started warming up. I would be very happy to see your response, right? If you are able to solve, please share your answers, right? Let's continue with the next one. Right, so we'll be looking at diverse kind of questions. For example, this next one, something on algebra, clearly variables x and y, right? Let's jump in. Let's see. What is the value of x square plus y square? Right, as simple as that. Okay, so both statements give some kind of equation in terms of x and y, right? Let's see. So look at statement 1, right? So you can see, so we need x square plus y square, and we are given x square plus y square, and then other terms are also there, minus 8x plus 6y plus 25. So it looks like, okay, there is only one equation in terms of two variables. How can we solve for anything, right? We don't know. I mean, we know that in algebra we need as many equations as are the number of variables to solve the equation. But this is a catch question, right? This is not very basic question, right? Because you see 8x 6y, so you know the idea of completion of squares, right? So with equation 1, if you do that with x square minus 8x, so you will do x minus 4 the whole square. So that would take care of x square minus 8x, and plus 16 will come. And then likewise y square, and then plus 6y. So 6y, so you'll do y plus 3 the whole square. That would also take care of y squared 6y. Apart from that, 9. This constant term 25 is exactly matching with the sum of these two constant terms 16 and 9. So what I'm able to conclude that this expression is nothing but the sum of two perfect squares, and their sum is 0. No perfect square is ever negative. Each of these terms are greater than equal to 0. So for it to be equal to 0, each of the terms has to be 0, which means that x must be 4, y must be 3 is the only possible way that this equation can be satisfied. So we do know that x square plus y square is 4 square plus 3 square. Sorry, my bad. X is 4, y is minus 3, right? Because x minus 4 is 0 and y plus 3 is 0, right? So with that, your x square plus y square comes to be 4 square plus minus 3 whole square, which is 25. So statement 1 is very much sufficient. So the point is that, you know, on the surface level, right, it is easy to, you know, miss this point. So typically the data sufficiency questions come with some kind of trap, you know, whereby you neglect the way that, okay, sometimes a statement is going to be, you know, sufficient on its own basis, right? Although on a face value it might look like, how do we know, right? Because two variables, only one equation, how can we solve? But it can be, right? So question, we have analyzed the first statement, it is sufficient. What about statement 2? So statement 2, obviously you will square both sides. So you have square root on both the sides, square root of x square minus 1 equal to square root of 1 minus y square. Squaring both sides, x square minus 1 equals 1 minus y square. So very much we are getting that x square plus y square equals this 2. So this is also sufficient. And therefore, E statement alone is sufficient. Right? One thing I want to point over here. Statement 1 and statement 2 both are sufficient on their own. But the value of x square plus y square is not the same. Now you might be saying that, okay, so they are contradicting each other. So why are we still saying each statement alone is sufficient? Right? Some people have this confusion that, okay, we are not getting the same answer, so they're contradicting. So even both statements together are not sufficient should be the correct answer. But you have forgotten the first thing that I said in today's session. We have to do two independent analysis. So therefore, since the analyses are independent, so you don't need to ensure the same answer, right? So even if you're getting the different outcomes from both these statements, whatever you're getting, right, uniquely, but they are not matching, does not matter. You don't have to ensure the same value, right? Or even if it's a yes no kind of question, one statement says definite yes, the second statement helps us conclude definite no to the question asked, still we will say option D, right? So these nuances you have to be aware of, right, on data sufficiency. Let's see, right? With so therefore these small things we have to understand, right? Let's see. Okay, I guess another one on variables, right? More or less inequalities are there. Is x more than y, right? Okay, so very direct question: is x more than y, right? So statement one is saying x square is more than y square. Not sufficient. Why? 5 square is more than 4 square, and 5 is more than 4. 5 square is also more than the negative 4 the whole square, but 5 is not more than minus 4. Sorry, my bad. Minus 5 the whole square is more than 4 square, right? Minus 5 the whole square is more than 4 square. So, but minus 5 is not more than 4. Minus 5 is less than 4. So if x square is more than y square, then x may be more than y or x may be less than y. So therefore, statement 1 is not sufficient. So in yes no type questions, if the sufficiency is not there, if we are having the possibility of both yes and no. So typically what is the approach that we do is that we try to create two scenarios where yes is also possible, no is also possible. So the approach is sort of, trying to disprove the sufficiency by saying that, okay, both yes and no scenarios are there, so statement is not sufficient. Come to statement 2. Statement 1 is not sufficient. Statement 2 is logarithmic inequality. It's saying that log x is more than log y with a common base a on both of them. Log x is more than log y. So x is not necessarily more than y because the graph of log x depends on the value of the base. If your base a is more than 1, this is the graph of log, which is an increasing graph, right? Always increasing. If your base is between 0 to 1, then your graph is a always decreasing curve, right? So in this case 1, if log x is more than log y, so let's say this is y1 equal to log x, right? This is x and this is log x, and this is y and this is log y. So log x is more than log y and x is more than y. But in this case, so log x needs to be more than log y. So this value will be, let's say, more than this one. So this is your log x and this is your x and this is your log y. So log x is more than log y and this is your y. But in this case, x is less than y because this is a decreasing graph, right? So x still may be more than y, maybe less than y. We still don't know. So this is also not sufficient. And then So therefore now we have to combine, right? So therefore we have to combine, right? Now, each statement alone is not sufficient. What happens if we combine? Now you come to the first example that we took. Remember that when we said that x could be less than y, did you see that we took a negative value of x? So the point is that when we combine, we are not allowed to take negative values of x, because logarithmic function is only defined for positive values of the input variable, right? So since you cannot take negative values, right? So you cannot have that scenario where x is less than y but x square is more than y square. Can you have? Just think about that. Okay, so think of all the possibilities where x square is more than y square but x is less than y. What kind of possibilities could be there? Like the one I have taken, right? Also I could have something like minus 5 the whole square is more than minus 4 the whole square, right? That also is a one possibility where x square is more than y square. And in this case also x is less than y, right? Minus 5 is less than minus 4. So since we can, so I mean, these two kind of possibilities, right, where x is negative, y is positive, or x and y both are negative, in those kind of scenarios only we can have that kind of scenario where you're having x to be less than y despite x square being more than y square. But since you are not allowed to take negative values now, so this is not possible. So since you cannot take this, so therefore after combining, can we say that x must be more than y? Are you getting the point? Right? And therefore both statements together are sufficient, but neither alone. Because with each statement alone, x could be more than y, x could be less than y, both possibilities are there, right? But one thing we're still forgetting, the second statement, even if both x and y are positive, despite that, when base is between 0 to 1, still still it could be possible that x is less than y. Now think about this. When I mean, let me complete this thought process. So we have analyzed about negative numbers, right? Now when the numbers are positive, right, so x square needs to be more than y square, so this kind of possibility is there, right? And log x needs to be more than log y to the common base a, right? So both the statements need to be satisfied simultaneously. Okay, so could it be, so I mean, could it happen that I can take these kind of numbers and satisfy this inequality? See, the point is that when x needs to be less than, when we are concluding that okay, log x, that x is less than y, and despite the fact that log x is more than log y, then uh, the value of x is less than y. But with this kind of numbers, we cannot satisfy x square to be more than y square, right? So since this will not be satisfied, so the scenario of x being less than y will not arise even with positive numbers, right? So that is why option C is correct. So very analytical question over here, right? Okay, let's continue. Right, so are you getting the point? How you have to carefully think through, right? A very deep analysis is required. Next one, here we go. Okay, so I think guess something on geometry. Is the quadrilateral PQRS a rhombus, right? Good. So some conditions, right? So basic properties you should know of quadrilaterals, right? The statement one is saying that diagonals meet at a right angle. So think about that. You have looked at all the different kind of quadrilaterals, right? Rhombus, parallelogram, trapezium, blah blah blah. Right. So which kind of quadrilaterals will satisfy this condition that their diagonals meet at a right angle? You very much know that that it does happen for a rhombus, right? For a rhombus, the diagonals do meet at a right angle. But this is not the only kind of a quadrilateral in which this kind of thing happens. It also happens for a kite. kite. What is a kite? In which two pairs of adjacent sides are equal. This is equal to this and this is equal to this. Even in a kite, the diagonals do meet at a right angle. So if this condition is there, then both yes and no scenarios are there. It could be very well a rhombus or it may not be. It may well be a kite. So therefore, statement 1 is not sufficient. By the way, what is a rhombus? The basic definition of a rhombus is all the four sides are equal, right? That's a rhombus. So both rhombus and kite satisfy. So therefore, both yes and no scenarios are. It's a yes no question. It's a binary question, right? Is this a rhombus? Yes or no? Statement 2 is not sufficient because two sides are equal. PQ equals RS. So all four may not be equal, right? So for example, something like this could, I mean, it could very well be a rhombus, right? If PQ equals RS, maybe also PQ is also equal to QR is also RS is equal to SP also. But I mean, something like this also could be there. This is PQ, and let's say, I mean, it's a let's say a rectangle, right? This is PQRS, and it may be a rectangle, right? So I'm saying no is also possible with something like a rectangle. So therefore, each statement alone is clearly rejected because both yes and no scenarios are possible. Now we combine. What happens if we combine? If we combine, then either rhombus or kite from statement 1, but PQ equals RS. So in a kite, if you say that this is PQRS and if this side is equal to this side, so eventually all four sides are forced to become equal to each other, right? So therefore, after combining, the case of kite is ruled out. Kite will also become rhombus. So eventually it must be a rhombus. So yes, both statements together are sufficient. Right, so classic question where each statement alone was not sufficient, then you combine and then you conclude that yes, after combining both the statements, both the conditions finally help us conclude it must be a rhombus, right? Okay, so why don't you share your answers with me, people? Right, let me know you're also there, right? Any queries, any doubts you can ask, right? Let's see next one. Here we go. Okay, again I guess something on geometry. Which is the greatest angle of triangle ABC? So you have to just identify which angle amongst the three angles ABC is the largest. Statement 1: AB square plus BC square is more than AC square. So this kind of condition reminds me that okay, this kind of condition is suitable when we are analyzing whether the triangle is acute angled or obtuse angled triangle, right? So we know that if the sum of if the sum of the squares of two sides is more than the square of the third side, then at least we can say that AC square. So let me draw the triangle, right? At least what we can conclude with this is that AC square is less than AB square, so plus BC square. So at least we can say that the angle opposite to side AC is acute angle, right? This angle must be less than 90 degree. Angle B is acute. But but then this condition does not help me to decide which is the greatest angle, right? We only are able to conclude one thing, that angle B is acute, nothing else apart from that. Which angle is largest? Difficult to say because we don't know anything about the other two angles. This triangle might very well be an obtuse angle triangle or an acute angle triangle. We don't know because right we do not know that AC is the largest side. Remember, right? So statement 1 is not sufficient. We can't conclude much. But come to statement 2. One of the basic tenets of triangle is that the larger the side, the larger the angle opposite to it. The sides and the angles are in the same increasing order. So AB is the largest side. So the angle opposite to AB, which is the angle C, must be the largest. Statement 2 is sufficient. Answer is B. Sides and angles are in the same increasing order. So AB is the largest side. So angle opposite to that is angle C. That must be the largest. So angle C must be the largest, right? and then BC is the middle side, so angle A is the second largest, and AC, so angle B is the smallest. So we know the definite order of the angles, right? So, right, you should know the so very basic of the most basic thing of triangle, right? Sides and angles are in the same order. All right, so we are looking at diverse concepts, right? Let's see next one. Okay, so a tank contains a mixture of milk and water. What fraction of the mixture is milk? Hmm. A tank contains a mixture of milk and water. What fraction of the mixture is milk? Two statements, first and second, look quite similar to read, but there's a big difference. First one says, if 10 liters of the mixture are removed and replaced by water, if 10 liters of the mixture are removed, and so removal and replacement is happening, the tank has 60% milk. Okay. The first thing that comes to my mind is I know 10 liters being removed, but I don't know the total volume of the mixture. So I don't think so that this might be sufficient, because I know what volume is removed, but I don't know what fraction of the solution, what percentage of the solution is removed. So since I don't know that, so now two variables are created. First of all, I did not know the ratio of milk to water. Secondly, I don't know the total volume of the mixture. So with this statement, we can't solve. Likewise, from statement 2 also alone, we can't solve, because it is also very synonymous equation. If 10 liters of the mixture are removed, replaced by milk, the tank has 15% water. So I guess easy to reject each statement on its own basis, right? I think only combining might help us to get the answer. So let's confirm that after combining, can we conclude the definite ratio of milk to water? So since we're finding the fraction of milk, let's call that as a fraction f. So if f fraction is milk, so 1 minus f fraction will be the remaining of water. So we are taking the variable f for the fraction of milk, and then the remaining 1 minus f is the fraction of water. So statement 1, what we can write now, we need one more variable, which is, let's call as v, for the total volume of the solution, because clearly we have to work with that, right? Because 10 liters is there. So in first case, we are diluting milk because water is being poured in, so the fraction of milk will go down. So the final fraction of milk will be is 60%, by the way, we know that, and that will be its initial fraction. So f into 1 minus 10 by v, right? Because that's the basic thing of removal and replacement, that the percentage of the thing which is being diluted decreases by as much fraction as you have removed the fraction of solution. So you have removed 10 by v fraction of the solution. So 1 minus 10 by v. So negative change on the fraction of milk will be by this much, right? So this is equal to 3 by 5, because you have now 60% milk, is my first equation. So that's why I was saying statement 1 is not sufficient, because what we can write as the equation corresponding to that creates one more variable, which is v, right? So I guess from second statement we can get a similar kind of equation, two variables, two equations we should be able to solve. Just ensure that it's a equation that can be solved. Let's write the equation for the second one. 10 liters of the mixture removed, replaced by milk. So now since we're replacing with milk, so water is being diluted. So the equation on the fraction will be written on not the fraction of milk, but rather of water. That 1 minus f is a fraction of water. It will decrease by the, again, 1 minus 10 by v, and that is equal to 15%, or 15 by 100, or 3 by 20 fraction of water. So yeah, very much looks like we should be able to solve the value of f, because we can divide the two equations, we should be able to solve. Let's quickly confirm, are we able to get a valid answer? Dekho, what happens is, what if you get the value of f to be invalid, something like f is 1.2, right? So the equations should give us a valid answer, that you need to check. We know we can solve, but are we getting a valid answer? For that, just calculate the value, right? So divide the two equations, because clearly 1 minus 10 by v will cancel. So f over 1 minus f is 3 by 5 upon 3 by 20, which is what, 4. F therefore equals 4 minus 4f or 5f equals 4, or f is 4 by 5. So yes, very much a valid value. 80, we started with an 80% milk. So after combining both statements together are very much sufficient, right? Okay, so this was how we do this, right? Question on removal and replacement concept, right? So you see, right, how data sufficiency we have to think in a different way, right? We have to properly follow the structure. Don't right be in a hurry. Okay, let's combining, right? That's not the way. Always first reject or accept that whether each statement alone works or not. Only when both statements individually fail, only then you combine, right? Let's see next one. Okay, something again on variables. Let's see. And modulus, right? Modulus. Again, it's a yes no kind of question. Is mod of a minus b equal to mod a plus mod b? Think about that. When will it happen that mod of a minus b equals mod a plus mod b? First of all, it's a yes no question. So when will this happen? Only unless you don't understand कि ये कब होगा, तब तक आप क्वेश्चन को नहीं अप्रोच कर सकते हो, right? So when will this happen? So think about this. If both the numbers a and b are, let's say something like, let's say positive, let's say 6 minus 5 mod. So mod of 6 minus 5, is it equal to mod 6 plus mod of negative 5? No, it is not. So this won't work if a and b are both positive. But what if, so in this case, I have taken a to be 6, b to be 5. What if I take a to be 6 and b to be, let's say, negative 5? So mod of 6 minus of minus 5 means mod of 11, which is 11. Is it equal to mod 6 plus mod of minus 5? Yes, very much. This is 6 plus 5, 11. Yes. Or it could be other way around also. It could be that a is minus 6, b is plus 5. That would also work, because eventually mod के अंदर तो minus sign हट जाता है ना. तो mod में if there is, let's say, minus 6 and plus minus 5, so that also will work out. So basically, this condition will be satisfied if a and b are of opposite signs, right? Now, with this understanding, I think approaching the question is not difficult. Statement 1 is saying a plus b 0. Obviously, a plus b, sum of two numbers is 0. One has to be positive, other has to be negative. Statement 1 is clearly telling me a and b are going to be of opposite signs. So yes, definite yes for the question asked, that yes, this equation will be satisfied, right? Coming to statement 2, which is saying a by b is more than 1. So something like 6 by 5 is more than 1. Something like minus 6 by minus 5 is also more than 1. But if I take minus 6 upon 5, that is not more than 1. Or if I take plus 6 by minus 5 also, that is also not more than 1. So the point is, only when both the numbers are of the same sign, whether both are positive or both are negative, then this inequality is satisfied. So in this case, we have a definite no to the question asked. No, this equation will not be satisfied, because we know this equation is satisfied if a and b are of opposite signs, but we know that in order for this inequality to be satisfied, a and b need to be of the same sign. We are getting a definite no, so statement is sufficient because we are getting a definite answer to the question asked. I told you in DS questions where the question asked is a yes no type question, even if the conclusion is a definite no, it's a conclusion. You got an answer. Okay, no, it's not, that equation is not satisfied. So the statement is deemed to be sufficient. Sufficiency is achieved. We are not here to get a yes to the question. We are here to get a unique answer. That's the point. And even though you can see that both the statements are getting diverse answers, this is saying definite yes to the question asked. Yes, because a and b are of opposite sign. And this one is saying a and b are of the same sign. But we will mark the answer as D. Each statement alone is sufficient, right? So I guess this question resolves all the queries or concerns about yes no type questions of data sufficiency. Clear? Right? Okay, right? Let's see. अगला देखते हैं. Next one. Okay, let's read this. A store sells two sizes of cookie boxes, small and large. A store sells two sizes of cookie boxes, small and large. The average weight of all boxes in a shipment is 420 grams. How many large boxes does the shipment have? Hmm. Okay. Statement one is saying large boxes weigh 500 grams each, small boxes weigh 350 grams each. Obviously, I can conclude anything about the number of boxes. How many large boxes? Nothing is given about number of boxes. Statement 2 is saying number of boxes less than 25. So, okay, so what do I know about exact value? Right? It's just saying an upper boundary. Okay, it cannot exceed 25. Right? So very quickly we can reject E statement because clearly it is not sufficient information to work with and find the number of large boxes. Obviously, we have to now see what happens if we combine. So after combining, we know 420 is the weighted mean of 500 and 350. So that tells us that we can apply the alligation principle to get the ratio of the number of boxes, right? So each large box on an average is 500 grams, and each small box on an average is basically of 350 grams. And on the whole, the weighted mean of the weight of the boxes is 420 grams. So therefore, crisscross difference, this is 80, and 420 minus 350, this is 70. So 70, 80, so 7 is to 8, right? So 7 is to 8 is the ratio of the number of boxes. And if it's a ratio, so the number of large boxes should be like 7x, this should be like 8x, and 7x plus 8x, which is total boxes, should be 15x. So total boxes are less than 25, and what we are able to conclude is that they should be the multiple of 15. So they can only take one unique value because we cannot take the multiple of 15 apart from 15, because 15 into 2, 30 will exceed 25. So x can only be 1, and total boxes can only be 15, and large boxes can only be 7. So after combining, we're getting the unique answer. So based both statements together do help us to get the answer, right? Okay, so therefore, I hope this helps us to prepare for DS, right? Something that can come in any exam, maybe even right. If right, all of us, we know all of us are writing the tomorrow's exam. Very good to see all of you in the session, and even CAT can come up with DS tomorrow. Nothing is predictable, right? Although it has not come in a long time, but it's something that we must be aware of, right? Something we should know that, okay, if these kind of questions come, how to approach. Let me tell you that Zat on the recent times has been asking questions on DS in the recent years, right? Other exams also can come up. All right, so thank you, people. I'll all the best, right? All the best for tomorrow. Best wishes, right? Thank you so much. Thank you. All the best. All the best. Care Launcher mobile app, something that you should uh, make use of, right? Thank you. Thank you, everyone. See you.